The arithmetic with rational expressions is already largely covered in other videos. What I want to do is simply include one more, I guess you could say more advanced or slightly more complicated, more involved example of the adding and subtracting problems. So for situations in the homework that are a little bit more complicated than the examples that were in those earlier videos, wanted to have this one more here for you, where again what we're going to do is begin by worrying about finding a common denominator. We're going to go ahead and jump right in there, in fact, and start writing that common denominator in. For that first denominator, it's already factored, and we can go ahead and get started by writing that down as the beginnings of our common denominator. When we look at the second denominator, we're worried about anything else that might show up. So in our second denominator, we have an x plus 3, and the power of 2 means that there's actually one other factor of x plus 3 that would appear. In pink, we only have one factor of x plus 3. So we need for our common denominator to have that one more factor of x plus 3 to cover our bases. Now what that means for us is that we would want to have both fractions with that common denominator. Whoop. Oh, what the heck. We would want to have both of our fractions with that common denominator showing up. So this means that we're going to automatically move into the second part of our process here, where we would adjust both of our fractions. Our first fraction started out having in the denominator just these pink factors. So we have put in a new orange factor. So up on top, we already had the x minus 1. We're now going to need to throw in an extra parentheses x plus 3 so that we've dressed up the bottom and dressed up the top in a similar fashion. So we dressed up the bottom by putting in the extra x plus 3 in orange. We dress up the top by doing the same thing. In our second fraction, we already had the x plus 2 appearing. In the denominator of that second fraction, we had the pink x plus 3, and we had the orange x plus 3, but we did not have an x minus 2 originally. So this is new, and we're going to have to put in a new pink x minus 2 up on the top to, again, make sure that we dress things up appropriately. So these are the two steps in one: finding the common denominator, and then secondly, adjusting each numerator so that the top and the bottom have been dressed up appropriately for each fraction. Now I can work through the other more tedious steps where I actually would have to simplify those numerators, perform the actual subtraction work, and then eventually see if there's any sort of simplifying, aka reducing, that we can work out. So what that would mean for us here is that we would have to FOIL out the top and the bottom. Excuse me, not the bottom. We would have to FOIL out the top of each fraction. So the first fraction, foiling the numerator, would give us x squared plus 2x minus 3. Everything down there in the denominator would stay the same. Foiling out the second numerator would give us x squared minus 4. And for our denominators, let's go ahead and let's write those in a shortened fashion, where we have the x minus 2 and the parentheses x plus 3 parentheses squared. That gives us just a slightly shorter version of that common denominator. According to our rules, we have to do the subtraction as we have in the past. Let's be careful about that subtraction. Let's in fact be overly careful by having the first numerator inside parentheses minus the second numerator inside parentheses to make sure that we do not accidentally, somehow or another, make a mistake in working out that subtraction. Again, repeating that common denominator. By distributing our subtraction, we would get x squared plus 2x minus 3 minus x squared plus 4. And then we can combine like terms on the top. Our x squared terms will cancel out. We will have a 2x still showing up, and we will have a plus 1 still showing up. Since that is nice and direct, thankfully we do not have to go through any extra work of factoring the numerator. We can automatically say that the numerator does not have any factor in common with the denominator. Therefore, there is no reducing, there's no slashing out that can be performed. So we automatically have our final answer immediately coming up here without any additional work, except for that mental consideration. Can't factor the numerator, therefore can't slash anything on the top and the bottom, therefore we're done.